Good day, everyone! Today, I will be presenting my project titled Controlling DC Motor Speed using Arduino, Potentiometer, and Transistor Circuit. In this setup, we will combine electronic components such as a PMOS transistor, NPN transistor, a diode, a potentiometer, a 9 volts battery, and of course, the Arduino Uno R3. This project demonstrates how to control the speed and movement of a DC motor safely and efficiently using PWM signals. Before we begin, let me first introduce the components used: DC motor, our load, which we will control; 9 volts battery, external power supply for the motor; diode 1N4007 or similar, prevents back EMF and protects the circuit; PMOS transistor MOSFET controls power delivery to the motor; NPN transistor, for example, 2N2222, used as a switching control for the MOSFET; potentiometer, used to adjust the motor speed manually; resistors, to limit current for the transistors; breadboard, for clean and safe circuit wiring. Arduino Uno R3 generates PWM signals to control the motor. Now let's discuss how the components are connected. This is important because it affects both safety and motor performance. Connect the 9 volts battery, positive, plus to the drain of the PMOS transistor. Connect the negative of the battery to the Arduino GND to make a common ground. Connect one motor terminal to the source of the PMOS transistor. Connect the other motor terminal to battery negative. Place the diode across the motor terminals, with the cathode stripe side towards the positive. This protects from back EMF when the motor spins. Connect the gate of the PMOS to the collector of the NPN transistor. Connect emitter of the NPN to GND. Connect a 10K resistor between the PMOS gate and the 9 volts positive to keep the MOSFET off by default. Arduino PWM-P9 gives 1K resistor, gives base of NPN transistor. This allows the Arduino to control the PMOS using PWM without exposing Arduino to the 9 volts supply. Connect left pin to 5 volts, connect right pin to GND. Connect middle pin to AO on the Arduino. This will give us values from 0 to 1023, which we will convert to motor speed. Now, let's move to the Arduino program that controls the motor speed. In Tinkercad, after wiring, click Start Simulation. Turn the potentiometer knob slowly. You will see and hear the motor rotating faster or slower, depending on the knob's position. PWM output from Arduino will adjust the control signal to the NPN transistor gives, which modulates the PMOS gives powering the motor. This demonstrates how analog input can be used to control motor movement using PWM. 1. Purpose of the circuit. This circuit shows how to control a DC motor using an external 9 volts power source while keeping the Arduino safe. 2. Why use NPN plus PMOS combination? The Arduino cannot directly handle the 9 volts load, so the NPN transistor acts as a safe control switch. The PMOS transistor acts as a high-side switch, controlling power to the motor. Both together allow efficient, safe PWM motor control. 3. Role of diode. The diode protects everything from the sudden voltage spikes created by the motor's coil, especially when stopping. 4. Potentiometer function. Acts like a speed dial. Low resistance gives low speed. Higher resistance gives higher speed. 5. PWM control. PWM creates the effect of smooth speed control without overheating the Arduino pins. 6. Safety notes. Never directly power a motor from the Arduino. Always use external power plus diode protection. In this project, we successfully demonstrated how to control the speed of a DC motor using a potentiometer, Arduino, PWM, and a transistor switching circuit. The setup is safe, efficient, and useful for robotics, fans, small vehicles, and automation projects. Thank you for listening.